Right. Good afternoon. Good afternoon, everyone. I think Kashyap just now started. I'll give you a chance to talk. Please down the hand. Kashyap. Good afternoon, everyone. We have been discussing K-map minimization, and also we discussed prime implicants, essential prime implicants, redundant terms, then selective prime implicants. Can you please check my video and audio? Is it fine? Is my video and audio is fine? Yes, it is fine from my side because many have responded. It is fine from my side. Okay, thank you. Thank you for your response. Right. Thank you. Thank you, everyone. Again, some people are saying that video problem. I can't see you. I enabled my video. Please check if there is any problem from your side. I have enabled my video as well as audio. Yes, sir. Good afternoon. Right. Okay. What we discussed, let me revise the concepts about prime implicants and essential prime implicants. What is prime implicants and how to get number of prime implicants? What is prime implicants? A grouping which cannot be expandable is called prime implicant. A grouping which cannot be expandable is called prime implicants. What is essential prime implicants? After grouping for all prime implicants, be clear about this. After grouping for all prime implicants, going through each and every grouping, if a grouping is having special cube, then it is essential. Otherwise, it is non-essential. At least one cube, specially covered by that grouping only. It is not covered by any other prime implicant groupings. Then it is called essential prime implicant grouping. How to find number of prime implicants? The number of possible groupings which cannot be expandable is called number of prime implicants. The number of possible groupings which cannot be expandable is called number of prime implicants. Irrespective of whether it is required or not required in the final expression, you need to group all possible groupings which cannot be expandable. Number of possible groupings which cannot be expandable is equals to number of prime implicants. After finding all prime implicants, to decide whether it is essential or not, going through each and every grouping, if that grouping is having at least one special cube, can be more than one, at least one special cube, then it is called essential. Number of essential prime implicants is equals to number of groupings with special cubes. And redundant. So, a prime implicant grouping can be called redundant if it is covering only min terms which are covered by essential prime implicants. Considering a grouping which is covering min terms which are covered by essentials only. A non-essential prime implicants which is covering only min terms which are covered by essentials only. So each and every min term covered by essential prime implicants, then it is called redundant. Redundant prime implicant. Exactly, redundant is different. I'll explain later. With respect to prime implicants, when can we say it is redundant? Is a non-essential prime implicant, which is covering min terms covered by essential prime implicants only. Then it is called redundant. What do you mean by selective prime implicant? Neither essential nor redundant. That means a non-essential prime implicant, which is not a redundant, is called a selective prime implicant. A non-essential prime implicant, which is not a redundant, are called a selective prime implicant. I hope you are following the terms once again. Prime implicant, right? The larger grouping which cannot be expandable is prime implicant. Number of prime implicants equals to number of possible grouping which cannot be expandable. What is essential prime implicant? A prime implicant grouping is covering at least one cube which is not covered by any other prime implicant groupings. Then it is called the essential prime implicant. When can we say it is redundant? A non-essential prime implicant which is covering min terms which are covered by essential only. If you are going through a grouping, in that we have only min terms which are covered by essentials, then it is called redundant. What is selective prime implicant? A non-essential prime implicant which is not a redundant is called selective prime. Right? If anyone has any questions with respect to these words, you can type in the chat box. I said type in the chat box. Anjaneyulu. If you have any doubt, please type in the chat box with respect to these words which I mentioned. Pratik Pramod, I can't do anything from my side. Everything is fine. Please check from your side. I cannot do anything. Right? From my side, everything is fine. Many are able to see me. Please understand. You keep on messaging. Just I'm looking at your message, but I can't do anything. From my side, everything is fine. My video is enabled. My audio is clear. Many are able to see me. Many are able to hear me. So, few means yes, Gopal Krishna. Have already done Anjaneyulu. Once again, revising the concepts. That we do, if possible, Usha. Right. Right. Stop typing. Right. SPI is nothing but selective prime implicant, which is not a redundant, non-essential prime implicant, not a essential prime implicant, and it is not a redundant. Then it is called selective prime implicant. Neither essential nor redundant. I clearly mentioned in the statements also. I have written those. Some people are asking to write once again. No, already I have written. Let's go to that. Neha. Then check with your system. If possible, try to log in another system. Right. So if there is any problem in video or audio, yes, Venkana, wait. Right. With respect to video and audio, from my side, everything is fine. Please check from your side. If you're not able to, please use another system or another device. Deepa. No, Kashyap. Srikanth, wait. We covered many questions, not few. Right. So we have discussed what is prime implicants, essential prime implicants, redundant terms, and selective prime implicants. Now, find number of prime implicants, number of essential prime implicants, and redundant terms. And also minimal expression. Find. From now onwards, question is common. Find number of prime implicants, number of essential prime implicants, and minimal expression. Statement is common. Purna Chandra. Find number of prime implicants, number of essential prime implicants, and minimal expression. Okay, back up. Very simple. Let us see that. Very good. Some of you are doing very well. Let me help them, right? Let us find a number of possible groupings to say number of prime implicants. This is one grouping, second grouping, third grouping, and fourth grouping. Number of possible groupings is 4. Number of prime implicants is also 4. Number of possible groupings which cannot be expandable is 4. Number of prime implicants is 4. In these, how many groupings are having special cubes? In these, how many groupings are having special cubes? Just a minute. Please wait. Let me use annotation. Right. Okay, fine. So in these, how many groupings are having special cubes? Only two. How many groupings are having special cubes? The essential prime implicants. Wait, Manisha. The essential prime implicants are nothing but right. The essential prime implicants are nothing but the groupings which are having special cubes. If you are observing, this grouping is having special cube. This grouping is having special cubes. Prime implicants is prime implicants is 4. The essential prime implicants is 2. Because this grouping is having special cube, this grouping is having special cube, these two groupings are having special cubes. No more groupings with special cubes. Yes or no? No more groupings with special cubes. So, number of essential prime implicants is 2. Prime implicants is 4, essential is 2. Is wrong. Right. Most of you are waiting for that. Yes, it is wrong. Yes, I'm confirming it is wrong. Why it is wrong? Intentionally it is given wrong K-map. What is here? After 0, 1, next must be 1, 1. Next must be 1, 0. Not by mistake. It is intentionally given. It is intentionally given. So after 0, 1, next is 1, 1, but it is given 1, 0. That means whatever we have done, analysis is wrong. It is given wrong K-map. Let me adjust the K-map. Then we can see what is the answer for this question. A, B, C, 0, 0, 0, 1. Next 1, 1, 1, 0. It is 0, 1. Then what we can get here? These are minterms, right? If you are swapping 1, 0, 1, 1 column, this will be the K-map. I hope no one is having doubt. Why we have swapped the number, sorry, columns. It is given intentionally wrong K-map. That is the reason I'm adjusting this K-map. Then grouping is possible. 1, 2, next 3, 4, 5, 6 are wrong because already it is a quad. If you are grouping these two, it is becoming subgrouping. Subgroupings are not prime implicants. Because if you are using these two as a grouping, for which there is a possibility for expansion to 4, when there is a possibility for expansion, it is not a prime implicant. Point should be understood correctly. Don't use only two cube grouping always. As it is possible for 4, we are grouping 4. If you are grouping these two, there is a possibility for expansion of that grouping to quad is not a prime implicant. You can group, but it is not a prime implicant. Why? A grouping which cannot be expandable is a prime implicant. A grouping which cannot be expandable is a prime implicant. If there is a possibility for expansion, is not a prime implicant. Such that only two groupings. How many groupings are essential in this? Here it is essential. Here essential. Here essential. Here essential. That is wrong analysis again. What is it here? This grouping is essential because of this cube. This grouping is essential because of these. It can be more than one cube. Don't count how many cubes are specially covered. No, that grouping is having special cubes or not. That grouping is essential or not. Don't count number of cubes which are specially covered by this. No, this is a grouping which is having special cubes. In this we have 3. Yes, it can have more than one, not a problem. At least one cube it is mentioned. Yes, in this we have only 1, but in this we have 3. But total groupings is 2 which are having special cubes. So the essential prime implicants also 2. Prime implicants 2. The essential prime implicants also 2. Then minimal expression is what? This grouping is what? C plus AB. C plus AB. Correct? C plus AB. Because of wrong K-map, whatever we are getting is wrong. So, this is not my invention also, simply my observation only, how they can frame questions. It is already given. For your information, is already given in GATE CSC paper. Why I have been mentioning about this question is we are preparing 100% clearly. We are understanding the concepts, but the way they are framing questions is different to bluff us. In this GATE exam, they are trying to bluff us. It's a bluff game. Don't get bluffed. Observe what is given, what they are asking. If you are not understanding these, no one can help you in the exam. In class, I can help you. In preparation, I can help you. In the exam, no one will be there to give you a warning. It is given wrongly. You need to observe yourself. So be careful. Have some observability. Observe what is given. Observe what they are expecting. So if question is understood correctly, answer is there in the question itself. Right? Yeah. Ashistosh, I will answer that question soon in the next slide itself. Right? Bharat, what happened? Number of prime implicants is 2. Why? If you are having a doubt. What is the number of essential prime implicants? Number of groupings which are having special cubes. Number of groupings which are having special cubes. When can we say it is essential? If a prime implicant grouping is covering at least one cube. At least means it can be more than one, right? So it is having a special cube. So this grouping is essential. I'm talking about number of grouping which are essential. I'm not counting number of special cubes. Number of essential prime implicants or number of groupings with special cubes. The special cubes can be one or more than one, not a problem. So this grouping is having special cube, so it is essential. This grouping is also having special cubes. Why? This is specially covered by this only. This is specially covered by this only. This is specially covered by this only. That means this grouping is having special cubes. It is having 3 special cubes, but 3 essential prime implicants will be wrong because we are confirming grouping is essential prime implicant. Grouping is essential prime implicant. So I'm not counting number of special cubes. I'm counting number of groupings with special cubes. Point should be understood correctly. I am counting number of groupings with special cubes to count number of essential prime implicants. Yes, this grouping is having special cube. This grouping is also having special cubes. So these 2 groupings are essentials. Number of groupings is equals to number of prime implicants. Number of groupings with special cubes are essential groupings. Still anyone is having any doubt? Still anyone is having any doubt? The essential prime implicants is 2. Right. Okay. Let me take the same question. If the given K-map is correct, I'm going with the same question. I'm writing in the next slide. This question I'm writing in the next slide once again. If that K-map, in that K-map, if the given order is correct, then what should we do? 0, 1, 1, 1, 1, 0. So assume that by mistake it was given 0, 1, 1, 0, 1, 1. Now, if it is given like this, what will be the solution? What is the question? Number of prime implicants, number of essential prime implicants, and minimal expression. For that, let me group 1, 2, 3, 4. How many groupings are possible? Four groupings are possible. How many prime implicants, sir? Four prime implicants, sir. In which, how many groupings are having special cubes? Yes, this grouping is having special cube. This grouping is having special cube. These two groupings are having special cubes. So these two are essential prime implicants. Point should be understood correctly. Number of groupings is equals to number of prime implicants. Number of groupings with special cube is equals to number of essential prime implicants. This grouping is having special cube. This grouping is having special cube. So two groupings are having special cubes. Then essential prime implicants is 2. So prime implicants is 4. Essential prime implicants is 2. No doubt in that. No doubt in that. Now let me write minimal expression. Yes. First let me write essentials. This is essential. What is the term we are getting? B bar C. Plus what is this grouping? B C bar. Now before that I need to do coverage of minterms by essentials. Coverage of minterms by essentials. Is it covering all? No. It is not covering this one minterm. Then to cover this one minterm, I have to choose non-essentials. I have to choose non-essentials. Understand point correctly. The essentials are not covering all the minterm. Then we get non-essentials also in minimal expression. While choosing non-essentials, I clearly mentioned minimum complexity must be there while choosing non-essentials also. In the previous example, if you remember, what is it here? To cover minterms which are not covered by essential prime implicants, we need to consider non-essential prime implicants in minimal expression with minimum complexity. While choosing non-essentials also, we need to observe whether it is minimum complexity or not. If we are having other possibilities, so we need to go with minimum complexity one. In this, we have one minterm which is not covered by essential. To cover this one minterm, I have to choose non-essential. To cover this one minterm, we have two possibilities, either this or this. So if I choose this one, it is covering minterm. If I choose this one, it is covering minterm. But which one should I consider? Whichever is covering with the minimum complexity. Yes, if I choose this one, resultant term will be AC. Am I clear? If I am choosing this one in the minimal expression, the term is AC. If I choose this term, then the term is AB. Check it correctly. If I choose this grouping in the minimal expression, resultant is what? AB. If I choose this one, it will be AC. Which one is correct? Both are having same complexity. These two are covering with the minimum complexity. Once again, this one minterm covered by this grouping, we have two non-essentials. Both are covering the minterm which is not covered by essential. Then which one should I consider? Whichever is covering with minimum complexity. And with respect to complexity also, this is resulting AC, this is resulting AB. Both are having same complexity. Then there is no priority. You can use AC or you can use AB. Both are having same complexity. Then we are getting two minimal expressions. Both are correct. Both are correct. Both are correct. Which one is correct? Both are correct because both are having same complexity. Both are functionally equal. Right? Functionally equal. So B bar C plus BC bar plus AB or B bar C plus BC bar plus AC. Both are correct. Once again, essentials we have considered. After that, we are observing one minterm is not covered by essential. To cover this one minterm, I'm choosing non-essentials. While choosing non-essentials, again here we have one possibility, we have second possibility. In these two possibilities, which one is having minimum complexity? Both are having same complexity because the term extra will be either AC or AB. Even though you are including AC, even though you are including AB, both are having same complexity. Then when complexity is same, I can choose any one. In such cases, we are getting multiple minimal expressions. Right? We are getting multiple minimal expressions. Point should be understood correctly. What we are getting here? Multiple minimal expressions. What is the reason for getting multiple minimal expressions? Concept is very important. Theory questions we have been getting. And they have given a question. Some number of prime implicants and essential prime implicant number specified. Then number of possible minimal expressions. Question is given already. Such theory questions they have been framing. Try to understand each and every concept correctly. Getting answer for the given K-map is not sufficient for competitive exams. What we are applying concepts in that is very important. Once again, I'm mentioning, I can complete the chapter with few examples which they are not very complex. Then you may be feeling comfortable. Subject is very easy. Subject is becoming easy because I'm not covering everything. If I try to cover concepts, then obviously there will be little bit strain in understanding the concept. Yes, if you are getting strain in understanding, that means you are learning. You are not here to verify your concepts. You are here to learn the concepts. Be clear about these words. So if you are feeling bit strain, be happy. You are learning something new, which is required for competitive exams to clear coming GATE and ESC exams. Be clear about my words, sir. Right. Yes. Pranav, unnecessary complexity is increasing, right? Why do you want to use AC plus AB both in the expression? Why do you want to use? Including AC is sufficient, including AB is sufficient. If you are including, then what happens? If you are including both, number of gates will be increasing and complexity will be increasing. What is that complexity? I'm going to talk in the next slide. Be clear about this. What we are discussing here? We are getting here two minimal expressions, not only one. We are getting two minimal expressions. We are getting two minimal expressions. What is the reason for these two minimal expressions? Lal Krishna. Wait. Right? What is the reason for getting two minimal expressions? Right. Listen, listen, listen. I'll make a statement and I'll make a note also for your reference. Just listen to me. What is the reason here? There are minterms which are not covered by essential. Essentials are compulsory. With essential, there won't be any problem. But there are minterms which are not covered by essentials. To cover these minterms, we are observing multiple ways with minimum complexity. Right? So, using non-essentials, if you are trying to cover minterms which are not covered by essentials, there we are observing multiple ways with same minimum complexity. That is the reason there is no priority which one should I choose in these. Then you can consider any one of these. When you are getting such situations, we can have multiple minimal expressions. What is it here? When we are trying to cover minterms which are not covered by essential prime implicants. In that case, right, if you are observing multiple ways with the same minimum complexity, then we will be in confusion. Which one should I consider? Then there is no priority. You can consider anyone because complexity is same, coverage is same. Our aim is to cover all. To cover all, there are some minterms which are not covered by essentials. Essentials are compulsory. There are minterms which are not covered by essential. To cover these minterms, we are choosing non-essentials. In that, we are observing multiple possibilities with the minimum complexity. Then we get multiple minimal expressions. Once again, I'm repeating, right? Please give your 100% presence in my words. You will understand. I'll make a note. if there are min-terms which are not covered by essential prime implicants. To cover these min-terms which are not covered by essential, we are choosing non-essentials. While choosing non-essentials, again we are observing multiple ways and also with same complexity. Then we are getting multiple minimal expressions. Right. Let me make a note. Everyone should understand. To cover min-terms which are not covered by EPIs, if there are multiple ways with, not only multiple ways, with minimum complexity, that is important. With the minimum complexity, then we get multiple minimal expressions. I think I did what I wanted to cover. Yes. Yes. With the same, yes, sorry. With multiple ways with the minimum complexity. Minimum can be only one, right? Same or with minimum complexity means with same. Someone is suggesting that same minimum complexity. Minimum means only one will be there. Is there any possibility for having multiple for minimum? Yes, equal in complexity. That too, that is minimum. You may be choosing that other possibilities also having same complexity, but that is not minimum. Then again it will be wrong. Yeah, Vamshi Krishna, that is relatively we can say, but not perfectly. Vamshi Krishna. Relatively we can say, but perfectly we cannot confirm. To say perfectly it is redundant, it must be covering min-terms which are covered by essentials only. That is not possible in this case, right? So while choosing one, the other one is becoming extra. But can we say perfectly which one is extra in this? No. That is the reason these are called selective prime implicants. The two selective prime implicants. But which one is redundant in this? I cannot confirm. So to say it is redundant, it must be covering min-terms which are covered by essentials only. Is it there in this? No. If one is already considered, confirm that the other one is becoming extra. But to say it is redundant, it must be covering min-terms which are covered by essentials only. Huh? Yeah, nah. Yes or no? Are you there? We should enjoy the concept, sir. Don't feel it is a very big concept, very simple concept. Problem is we are assuming some things. Problem is in graduation generally we assume, but in GATE and ESC preparations also, if you go with assumptions, there is a possibility for doing mistakes. Yes, that's what I'm going to talk, Mangesh. Right? Whenever you are talking about complexity of a expression or minimum complexity, we have been using that minimum complexity. What do you mean by minimum complexity? Please respond in the chat box. What do you mean by minimum complexity? What do you mean by minimum complexity? minimum variables, minimum gates, minimum literals, minimum terms, minimum number of cubes, right? Okay. Less number of literals, right. Okay. Okay. Right. Reducing the circuitry. Okay. Should not be lengthy. Expression should not be lengthy. Okay. To reduce the circuitry. Yes. Okay. What do you mean by minimum complexity? Minimal. What do you mean by minimal expression? When can we say it is minimal? Correct. When can we say it is minimal? Right. Listen. When can we say it is minimal? Final. What do you mean by final? Further reduction is not possible. Points one by one, I'm explaining. What do you mean by minimal? Final expression. What is final? Which cannot be minimized further. Right? So, minimal, final. What is final? Further reduction is not possible. Further reduction of what? Further reduction of what? Further reduction of what? What happened? Bhanu Prakash Reddy? Why did you get it out? Your response is visible. Do you have any doubt? Or did you feel that I did not respond for your query? Right. Okay. Listen. Please don't type anything. Please listen to me for a few seconds. I'll talk to give you some more clarity. Right? Okay. Minimal, final. What do you mean by this? Further reduction is not possible. Further reduction of what? Complexity. Again, getting it out. What do you mean by complexity? How do you measure the complexity of a Boolean expression? How do we measure complexity of a Boolean expression? Simple. Listen. If I have an expression like this, AB, A bar C plus BD is the expression. AB plus A bar C plus BD is the expression. Let me implement this expression using two-level basic gate implementation, assuming all the literals are available. Point should be understood correctly. I'm going to give you how we can measure complexity of a Boolean expression. Understand correctly? So now, this expression should be implemented using two-level basic gate implementation, assuming all the literals are available. All the literals are available. To implement this in two levels, yes, sir, we have AND gate, we have another AND gate, we have one more AND gate with inputs AB, A bar C, BD. Two level means I need to use here only one gate. So complexity, you may be assuming that the complexity means number of gates. How many gates we have? 1, 2, 3, 4. Right? It is implemented using 3 plus 1, 4 gates. Complexity cannot be estimated with number of gates. Reason, the same circuit you have implemented like this. I'm going to implement in another way. Listen carefully. What is it here? The same Boolean expression, you have implemented this. I'm going to implement another way. Let me show you my implementation. Will it be changing the functionality? No, because A bar C plus A bar C is A bar C only. Now, how many gates we have? 4 gates only. Earlier, 4 gates. Now, 4 gates. Now, also 4 gates. So difference you need to observe. I have used one more input here. Number of gates is 4 only. If I measure complexity of this expression with the number of gates, it will be wrong, because complexity of 3 input gate, complexity of 4 input gate is not same, right? Complexity of 3 input gate, complexity of 4 input gate is not same. That means what is the other way to measure the complexity of Boolean expression is what is it? Don't count only number of gates. Number of gates plus number of inputs of each and every logic gate also. How many gates we have? 4 gates. How many inputs of each and every gate? 2 plus 2 plus 2 plus 3. How much is that? 6 plus 3, 9. Complexity of this is 30. Listen carefully. I'm going to cover one more concept with this example also. Concept I'm covering, not giving any methods for counting. So I'm going to cover a concept here. Right. With the 2 examples have differentiated what is the reason for including number of inputs of each and every gate also while counting complexity of Boolean expression. While counting complexity of Boolean expression, number of gates plus number of inputs of each and every gate. Understand point correctly? The given Boolean expression should be implemented using 2-level basic gate implementations, assuming all the literals are available. Because I'm not counting about A bar also. If I count A bar, the complexity will be different. That is the next level analysis we can do. But here at this level, remember this. By implementing given Boolean expression using 2-level basic gate implementation, assuming all the literals are available, if you are counting number of gates plus number of inputs of each and every gate, then you can measure the complexity of Boolean function. Boolean expression complexity we are counting or measuring. How? By implementing the same expression using 2-level basic gate implementation, assuming all the letters are available, we are counting number of gates plus number of inputs of each and every gate is giving complexity of given Boolean function. Right? Minimal expression, minimum complexity. That means further reduction of this number is not possible. Then it is called minimal expression. So, minimal expression, minimum complexity. What is minimum complexity? Further reduction of complexity is not possible. Further reduction of complexity means what? Further reduction of this number is not possible. Then it is called minimal expression. Right? Should focus on this. Please listen. Please listen correctly. Yes, this number cannot be minimized further. Then we can say it is minimal. To reduce this number, we can reduce either this number or we can reduce this number also. See correctly. Our aim is to reduce the complexity. To reduce this complexity, this number is indicating complexity. You can reduce either this or this. What is this? Number of gates. Then what is this? Number of inputs of each and every gate, which is also named as a fan-in of logic gates. Right? What is it here? Fan-in of logic gates. So this number is what? Number of gates. This number is what? Number of inputs of each and every logic gate, which is nothing but a fan-in of a logic gate. Fan-in of a logic gate. So now number of inputs of a logic gate is nothing but fan-in of a logic gate. Number of outputs it can drive or number of similar logic gates it can drive at output side is called fan out. Fan out. Fan in is number of inputs it can be connected is fan in. Number of standard logic gates can be connected at output side is called fan out. At this moment we need fan in. Yes. To reduce the complexity, you can reduce number of gates, you can reduce number of inputs of each and every logic gate. Right. Right. Based on this, let me discuss a question which was already given. Now, if you understand this question, you may understand importance of this concept. Right. Listen. Minimization of Boolean expression using K-map is once again, minimization of Boolean expression using K-map is dash. Once again, minimization of Boolean expression using K-map is dash. Option A, reducing number of gates. Option B, reducing fan-in of a logic gate. Option C, both. Option D, none. Once again, question and options. Minimization of Boolean expression using K-map is dash. Option A, reducing number of gates. Option B, reducing fan-in of a gate. C is both. D is none. Which one is correct? Yes, yes, yes. 100%. Now you are understanding. Ravi Teja. Bhavani. Check it. It is reducing number of gates. It is reducing fan-in of a logic gate also. Final number minimization is depending on, it can be reducing number of gates. It can be reducing number of inputs of a logic gate also. It is both. It is both, not only fan-in. Don't remember fan-in only, Manikanta. A and B both. For that we have option C. You have mentioned A and another time you are saying B. Now it is A and B. That means it is a both. It is the question which was given in previous exam. Understand correctly? This is a question which we got in the previous exam. Yes. Yes. Yes, Manika. Now you are correct. Just check it. Don't be in a hurry. Nagalingeshwar Rao. When I am talking about a very good concept, now you are pulling me into SPI EPI again to define. When I was explaining about SPI EPI from yesterday, I have explained minimum 5 times today. Please understand correctly, right? So when I'm discussing about complexity, now you are saying about SPI and EPI. That means your mind is still engaging with SPI and EPI. Then when do you understand this complexity? When are you going to understand about complexity? When are you going to understand about question which I am discussing now? If you are typing, yes, yes, Manikanda, I'll do that. Yes, I do that. Right. So when I'm explaining seriously about complexity and so, you are saying about SPI, EPI means your mind is engaging with that. Now, after completion of this, when I'm in next topic, what do you say? Sir, how to estimate complexity? Right? Please. When I'm in a concept, please be in that concept. Then mutually it is helping us. Right? So, when I'm moving to next topic, when you are in the previous topic, then you will be lagging again with this topic. Again, next topic, same. Once you are lagging, throughout the session, you will be lagging. Please. No need of sorry. Mr. Nagalingeshwar Rao. I never expect that. I never expect thanks also. I never expect sorry also. I'm doing my duty. Because my duty is conveying the concept, conveying how to prepare for the exams. So to set your minds, I've been mentioning all these words. Not only you, some of your friends also may be same. So as I am observing you, I'm mentioning your name, but particularly I'm not having any intention to say you personally. No, it is for everyone I'm mentioning, not for you. Don't, no need of sorry, no need of thanks also. I never expect that. Right? Please. Right. Harish, fan out is nothing but the number of standard gates it can drive. It can drive. That you need to understand. What do you mean by can drive? When it is producing logic 1, it must be treated as logic 1 by all the fan out gates. When it is producing logic 0, it must be treated as logic 0 by all the fan out gates. That is a fan out of a logic gate. Harish. Okay. Finally, what we have understood? This concept is also they have used to frame a question. Right? To frame a question. Yes or no? Yes. Every concept is important. But specially is not required to be mentioned in this specially. Why? If you are observing what is happening in minimization of Boolean expression using K-map correctly, I don't need to mention this separately. But people are understanding how to group, how to get expression. But what we are doing, what for we are doing, you need to understand. Yeah, Pranita, I will discuss about fan out and all, right, in logic families. Please hold on. So at this moment, fan in, you need to understand what is fan in. Number of inputs, it can be connected. Number of inputs of a logic gate is fan in of a logic gate. Yes, technical definition is there. It can drive. It can drive. That is a technical word. What do you mean by can? For example, a bipolar logic family is there. People have been asking because I introduced. That is the reason people are picking up that word. Let me explain. Yes, if I use a simple RTL logic family, it is producing output. It is producing output. Now, this output is connected to n number of logic gates. N number of logic gates. Understand correctly? It is connected to n number of logic gates. When this is off, when this transfer is off, it is producing logic 1 output. Am I right? Because it will be getting VCC. It is getting logic 1 here. Let me say it is RC, it is RB. So when you are connecting here logic 1 input, this transfer is on. Sorry, when you are applying a logic 0 here, this transfer is off. Then you are getting here it is logic 1 output. That means here it must be considered as logic 1 by all these transistors. That means all these transistors must be getting saturated. Am I right? That means whatever the current, it is off. It is off. Whatever the current we are getting here, that must be sufficient to saturate all these transistors. What do you mean by this? If I say IB minimum required to saturate these transistors. Am I right? Right. Yes, IB minimum, IB minimum, IB minimum. So N into IB minimum is equals to IC, or N into IB minimum must be less than or equals to IC. What is the N value can satisfy this equation, that is fan out. Technically, yes, there is a meaning for fan out. Right? Please understand these words correctly. Right? It may be useful later on. What do you mean by this? When input is applied here, logic 0, we are getting logic 1 here, because here it is off, here we are getting a logic 1. Then conditionally, what is it? You are getting current. So the current IC is not getting into this, total current is flowing like this. Then This current must be sufficient to saturate all this. Why? It is logic 1 means this transfer must be considered this as a logic 1. That means transfer must be saturated. For saturating, we know what is the current required. That is IB minimum. Right? By applying VC SAT, we can calculate that IB minimum of a transistor. Then we are calculating IB minimum. So then N into IB minimum must be less than or equals to IC. Then only this fan out is applicable, or whatever the maximum N value can satisfy this equation can be considered as a fan out of a logic gate. Fan out of a logic gate. Right? Pavan Kumar. Right? Shivalila. Praneeth. Happy? Enjoying? Fan out is nothing but the number of standard gates it can drive. You need to understand, right? Done? Are you there? Whoever was worrying about fan out, is it fine? Are you here? Are you understanding? Right? Yes. Technically, we can define fan out, but fan in simply number of inputs it can be connected is fan in of a logic gate. I feel now unnecessarily I have introduced a word fan in. Simply number of inputs is sufficient, right? Yes, fan in and fan out. When I discuss about fan in, then I mentioned about fan out. I'm very much happy because you are interested to learn. Many of you have mentioned about fan out. Sir, what is fan out? When you're asking, I feel happy because you want to learn. That's what giving me encouragement to give conception the right way. Thank you. Thank you for your interest. If you want to know, I'm there to help you. Right? Done? Right. So, minimum complexity is nothing but the minimum this number. What is that number is including? Number of gates plus number of inputs of each and every logic gate. If you are observing, right, complexity of this is same. Whatever the number we have calculated will be same for this, will be same for this. Which one is correct? Both are correct because both are functionally complete, both are having same complexity. Then which one should I consider? No limitation for that. Yes, you can use any one of these two. That is the reason we say that multiple minimal expressions. Maza aa raha hai? Are you enjoying? Once again, Kashyap. One example here I mentioned Rajendra Kulkarni. Fan out is depending on, in a particular logic family I mentioned, there is nothing but here, if you come to unipolar logic family, if you are coming to unipolar logic family, there won't be any current. The reason, ideally we say that CMOS infinite, but there are some issues while calculating propagation delay. If you keep on adding logic gates at fan out or output side, then what happens here? Here, what is it here? The gate capacitance of each and every MOSFET is getting added as load capacitance for this logic gate. You are pulling me into industry training, frankly saying that. But I'm not covering what I know. I'm covering which is required for exams only. Yes, there is a logic gate which is CMOS. Assume that. Here you are connecting that more number of gates. Then what happens here? Here load capacitance is nothing but internal capacitance of these devices in this logic gate and also input capacitance or gate capacitance of each and every MOSFET is connected here. That means the CL is increasing when number of gates at output is increasing. When CL is increasing, then propagation delay of this logic gate is calculated with the input transition time, output load capacitance. Input transition time, output load capacitance. So whatever the lookup table is mentioned for a logic gate, so this CL must be within the characterized limits. Then only the propagation delay we are calculating with the interpolation will be correct. If CL is out of limits of characterized limits of each and every logic gate, then you need to use extrapolation to estimate propagation delay of this logic gate. Extrapolation is not guaranteed. Interpolation and extrapolation you might have studied in numerical methods that we are using in calculating propagation delay. In IC design, when EDA tool is designed, that is a parameters it is used. So we are providing library or technical information to calculate propagation delay of each and every logic gate. In that, what will be their information is what is the input transition time, what is the output load capacitance. So there will be 7 by 7 lookup table of each and every logic gate for A to Y, B to Y, rising, falling, different logic gates, different delays will be provided with different load capacitance, different input transition time. Because input is changing, output is changing. Their propagation delay is there, but input is not exactly changing abruptly. Input is also driven by another logic gate. Then transition time and load capacitance are deciding propagation delay. Kulkarni? Yes. मजा आएगा, मजा आएगा. Yes, sir, Srinath, I'll take examples. Please wait. Right. So much is there in digital circuits, but let us understand what is required for our gate and ESC. This most of these things you are going to study in your devices and VLSI. Propagation delay, power dissipation, you are going to understand in CMOS, inverter characteristics, short circuit power, dynamic power, and all these you are going to study in your device VLSI for EC students, EC and instrumentation. I'm talking. Right. Come out of that, please. So, simple concept we have understood with this example is what is the minimization includes, which is reducing number of gates, which is reducing fan-in of each and every logic gate, which is nothing but number of inputs of a logic gate is also reducing. Because without minimizing, if you are implementing, it may be required to use 3 input AND gates or 4 input OR gates also. After that, what we have observed, directly if you are implementing, without minimization, if you are implementing an expression, you might have observed multi-input AND gates required, multi-input OR gate required. So number of gates is obviously minimized. The number of inputs of a logic gate is also minimized with this K-map minimization. So minimization of Boolean expression is reducing number of gates and fan-in of a logic gate also. How do you estimate complexity of Boolean function? Number of gates plus number of inputs of each and every logic gate. What is minimal expression? Minimum complexity. What is minimum complexity? Further reduction of complexity is not possible. Then it is called minimal complexity. What is it for minimal complexity? The number of gates and number of inputs of each and every logic gate is giving complexity of Boolean function. To measure complexity of given Boolean function, we are implementing the given Boolean function using two-level implementation, using basic gates, assuming all the literals are available, we are implementing. Then we are counting number of gates plus number of inputs of each and every. Right? Any questions? Any questions? Any questions? Full maza aega. Just we are in basics only. Once we are getting into combination and sequential, yes, I hope if you are interested, you will enjoy. If you are not interested, right, it is not offline class or physical class also to observe you whether you are following or not. Not able to see what you are understanding also, but get your interest, get your 100% presence in the class. Focus on my words. Every statement, every word, every concept is important for our competitive exams because the scoring subject, if you are clear in the concepts, otherwise a negative score will be there. Fortunately or unfortunately, the subject is either giving 100% or other possibilities, it is giving negative marking. Reason for this is, please understand correctly in a positive way about the subject. Because digital subject, what we feel, it is easy. We try to attempt the questions, or most of the questions we are trying to attempt. Then what is the possibility? If you are not understanding concepts correctly, there is a possibility for doing mistakes. If you are not attempting the question, happy. But with 50% knowledge, with 100% confidence, we are answering these questions. Then it is leading to negative marking. That is a problem with the subject. Easy when you are understanding concept, which can give 100% marks. If you are not 100% in the concepts, there is a possibility for doing mistakes with 100% confidence because we feel digital is easy. Yes or no? Right? Yes or no? Digital is easy, but we need to observe the depth of the subject also. Yes. Okay. Fine. So finally, what we have observed? Last concept is what? Right? Multiple minimal expressions. When we are observing, there is a possibility for covering min term which are not covered by essential prime implicants. If there are multiple ways, we get a multiple minimal expression. Multiple ways with the minimum complexity. Then we get a multiple minimal expression. After that, what we understood? A complexity concept. We have understood a complexity concept. Now, one more example. One more example. Find number of prime implicants, number of essential prime implicants, and minimal expression of function. Now onwards, you may be observing whether given K-map is correct or not, right? That's what my intention. Right? I need to educate you towards the competitive exams. I'm doing my best. So try to utilize that. Yes, 00011110. When such order is given, you are observing whether K-map given is correct or not because of previous, just before example. Right? Find number of prime implicants, number of essential prime implicants, and minimal expression of function. Number of prime implicants, number of essential prime implicants, and minimal expression of function. One, 2, 3, 4, 5, 6. How many prime implicants, sir? 6. Anyone is having any doubt? Prime implicants is 6. EPI, essential prime implicants, sir. How many essential prime implicants? Very good. Toyajakshudu, very good. Annapurni, excellent. Anand, very good. Very good. Right. Yes. Now you are in right way. Yes. Superb, superb, superb. Unable to check each and every message also. Yes. Most of you are responding correctly. Not most of you, all of you, I think. Number of essential prime implicants you are mentioning. All of you have mentioned correctly. How many? Yes, it is two only. Where do we have the two? Here we have special cube essential. Here we have special cube essential. Only two groupings are having special cubes. So the essential prime implicants is two. The essential prime implicants is two. Right. Now, let us see minimal expressions. First thing is what? The essentials we need to write. No doubt in that. The essential means compulsory. Without that, completeness is not possible. So, first one is what? A bar, B bar, C bar. Plus. This one is what? Essential. A, C, D bar. Plus. See, coverage of minterms is this much only by essentials. How many minterms are remaining? 3 minterms are remaining, which are not covered by the essential prime implicants. There are 3 minterms which are not covered by the essential prime implicants. To cover these, we have to choose non-essentials. Check it correctly, listen correctly, listen carefully. So, the essentials we have written. Okay, the essentials covering these two minterms. There are 3 minterms which are not covered by essentials. There are 3 minterms which are not covered by essentials. To cover those 3 minterms, we have to choose non-essentials. Correct. While choosing non-essential, listen. This one is what? A bar, C bar, D. Then this one is what? B, C, D. Right. Choosing this plus this. Will it be giving wrong? Same. Complexity is right. Covering is completed. Then other possibility. What is it here? If I choose this B, C, D, and if I choose this A, B, C. If I choose A, B, C. See here. If I choose this plus this, again two terms. And again, what is it here? Choosing this one is one and this one is other one. Check it correctly. Possibilities. This plus this, one possibility. This plus this, second possibility. This plus this, third possibility. All these three will be having same complex. Check it correctly. So this plus this one is what? A bar, C bar, D. A bar, C bar, D. Plus this one is what? B, C. Or other possibility. What is this plus this? This one is what? A bar, B, D. A bar, B, D. Plus this one is what? A, B, C. Or this is one and this is second one. This is another way. What is it here? A bar, B, D. Plus what is this one? B, C, D. So we are getting 3 minimal expressions. We are getting 3 minimal expressions. 1, then 2, then 3. We can have a 4 also. I don't want to give you now. I will discuss later. 4 minimal expressions are also possible in 4 variable K-map. I'll show you that later, not now. So finally, what we have understood here, we are getting 3 minimal expressions. We are getting 3 minimal expressions. Yes, we are getting 3 minimal expressions. So essentials compulsory. Then to cover these 3 minterms, we are observing this plus this one possibility, this plus is this second possibility, this plus this is third possibility. Let me take one more example. What happened, Manikanta? What is your doubt? What is your doubt? I'm not understanding with your message. One more possible equation. Sai Krishna, where is that? Check it, it is not there. Yes, SPIs. Shubham. Sai Krishna, one more is not possible. Check it. Only three possibilities. One more is not possible. Number of prime implicants, number of essential prime implicants, and first expression, last one is this plus this means here we are getting BCD only, it is not ABC. In the second one, we are getting what is it here? This plus this, here we are getting ABC. Let's check it. Someone is in confusion. ABC is there in the second expression. Check it correctly. Anikanta. With ABC also we are getting expression. Check it. So first one I am considering this plus this. This one is what? BCD only. See, possibility. First possibility I am considering this one plus this one. You may be considering order differently. Check it. With ABC also we have in the second expression. Manikanta. Manikanta, don't be in confusion, sir. Yes, thank you. Don't kids will be there. Hold on, Kashyap. For you. Wait, Kashyap. For this question, I'm asking you to find number of prime implicants, number of essential prime implicants, and minimal expression. Right. Let me do that. This is one grouping. Remember that we have octave. Don't group these four separately, these four separately. You can group, but those are not prime implicants. Yes. Second grouping. Right. Third grouping. Fourth grouping. And fifth grouping. Whether required or not, doesn't matter here. Whether it is prime implicant grouping or not, that's it. How many groupings possible? 5 groupings which cannot be expandable. Number of prime implicants is 5. Nagalingeshwar Rao, don't do the mistake. Observe correctly. Octave, first thing is octave. First thing is octave. Manikanta, wait. Right. These are possible groupings. How many groupings possible? 5 groupings possible. Any doubt in that? First one is octave. Remember, first one is octave. Let me group once again for you. What is first one? Listen once again. Listen once again. First one is octave. Because if I am grouping these 4, there is a possibility for expanding to octave. So it will not be a prime implicant if I am grouping 4. Yes, it is 8 is possible. So we are going with the expanded grouping, which is octave. That is one grouping. There is not 2 groupings, only one grouping. Next, second grouping is a prime implicant. Third grouping, prime implicant. Fourth grouping is also a prime implicant. Fifth grouping is also a prime implicant. No more groupings possible. Total 5 groupings which are prime implicant groupings. So prime implicants are 5. Correct if you are doing wrong. Please correct yourself if you are doing any mistake. Observe total prime implicants is 5. Last 4 corners. Annapurni. Yes. Correct doubt you have raised. Very good. See, you might be thinking that this is a quad. But including those 4, there is a possibility for 8. Or in this octave itself, we are choosing 4 is not a prime implicant. Subgroupings are not prime implicants. Corner grouping, Annapurni, please check it. See, if you are observing corner grouping, yes, you can group, but it is not a prime implicant. Why? For this 4, there is a possibility for expanding to 8. Or this 4 is a subgrouping of octave. Subgroupings are not prime implicants. Am I right? Am I right? Understanding? Right, Annapurni. I think you raised that corners, right? Very good. What is the need of last grouping? If you are talking about this corner grouping, it is wrong, I'm saying. If you're talking about last grouping, if you're talking about last grouping, what is it? Corner grouping? Yes, it is wrong, I'm saying. Are you talking about any other grouping? Someone was asking about last grouping. Manikanta, wait. First, let me complete SOP minimal. We are going for POS minimal. Why are you in hurry, Manikanta? Right, wait. I will discuss. I will discuss. Right? Yes. So, what we are saying here, if you are talking about this grouping or whatever, all these are prime implicant groupings. No doubt in that. Bhavani, I think you only write that corner grouping. Right? Yes. What happens if you neglect that last one or whatever you are saying that? Please wait. Please wait. I'll give you clarity. Now let me talk about. Okay, you are saying BC means B. Yeah, what is the need of that? You can understand now. Hold on. You are going to understand what is the use of grouping like this. Even though we have one knowledge, what is the knowledge also? I'll say. Please hold on. Please. Now, prime implicants are 5. Confirm. Please. Give me 5 minutes. I will continue. Later, I'll check your questions. Right now, prime implicants is 5. No doubt in that. Yeah, essential prime implicants. How many essential prime implicants? See, octave is having special cubes. Am I right? Octave is having special cubes. Correct. Now, this quad is having special cube. This quad is having special cube. So it is also essential. This quad is also having special cube. Essential. One by one. We need to find number of essential prime implicants is equals to number of prime implicant grouping which are having special cubes. Yes, octave is having special cube. Correct. Now, quad is having special cube. This quad is having special cube. This is special cube, right? What about this quad? No special cube. Why? 2 are covered by this grouping, 2 are covered by this grouping. So it is not having any special cube, non-essential. What about this quad? Is also non-essential because these 2 are covered by this, these 2 are covered by this. No special cube covered by this grouping also. So this is non-essential. This is also non-essential. So finally, how many essentials? 2 essentials. How many essentials? 2 essentials. Any doubt in that? Any doubt in that? Number of groupings with special cubes is equal to number of essential prime implicants. Yes, octave is having special cube, quad is having special cube, quad is having special cube. Yes, all these are essential. Right. Let me write a minimal expression. Before that, what should I do? Coverage of minterms by essentials. First, octave is essential. Correct. This quad is essential. This quad is also essential. Right. This quad is also essential. First, let me write essentials. Octave is essential, which is D bar. Quad is essential, AC bar. This quad is essential, A bar C. I hope you are following. To cover this minterm, we have to choose non-essentials. One non-essential is this, resulting AB. Another non-essential is this, covering this minterm. So, to cover this minterm, one possibility, second possibility. One possibility is AB, another possibility is BC. Which one should I consider? Anyone again. So, either AB or what is this one? BC. Both are having same complexity. Now we are getting again 2 minimal expressions. Again we are getting 2 minimal expressions. Right? One is AB, other one is BC. Which one should I consider? Both are giving same complexity. Anyone can be considered. Then both are correct minimal expressions. Now you might have understood what is the reason for grouping this. Right? Let me give you one important thing. If you are in a graduation, there is a question in final exam. Then what you might be doing is this. If the K-map is same, which is given like this, then no doubt, yes, we group octave, we group this quad, and this one, sufficient, right? So what we get here? D bar plus AC bar plus A bar C plus AB. Is this wrong? It is correct. But in competitive exams, this may be given in the options, this may be given in the options. Which one is correct? Both are correct. Yes, you are getting this answer. But if luck is not in our favor, then option may be given this one, right? Or the number of minimal expression of the following function, it may be given like this. Then what do you do? Then what do you do? Do you say only one? No. Yes, this grouping is also possible. Then B bar plus AC bar plus E bar C plus BC is another expression. Both are correct. Both are correct. If you are going with the graduation knowledge, you may be getting only one expression. Some people were asking that, why do you need last grouping? Bhavani. Right? Now you might have understood. Yes, yes, I will explain once again. I will explain once again. No need to worry. Essential prime implicants is 3. Correct. Most of you are doing. Right. After observing essential prime implicants, what we are doing? First writing essential prime implicants. After that, one minterm is not covered by essential. To cover this one minterm, we are observing two possibilities. One is this grouping AB, another grouping is BC. This is another grouping. This one minterm covered by this grouping or this grouping, or this grouping and this grouping. Which one should I consider? Anyone, because both are having same complexity. Both are giving coverage. Both are giving same complexity. Then which one should I consider? Anyone. Then we are getting again multiple minimal expressions. Multiple minimal expressions. EPI part is nothing but number of groupings. Yes, EPI is 3. Sorry. EPI is 3. EPI is 3. One is a octave. One is a octave because it is having special cubes. Second one is quad because of this cube is covered by this grouping only. This grouping is becoming essential grouping because it is covering this cube which is not covered by any other grouping. What about this grouping? Is also having this cube specially covered by this grouping only. Then these three are essential grouping. What about remaining two? This is not having any special cube. This is not having any special cube. These two are non-essentials. These two are non-essentials. Some people are raising hands. Wait till the end. So here we are getting two expressions. Yes, two are correct. If you are not grouping this one as a, people are asking, you are getting only one expression. If it is there in the options, you are lucky. If it is not there in the options, you may be thinking that options are wrong. You won't think that you are wrong, right? You may be thinking that the options are wrong. Second came up, 3 number is leaving. Emma, where is it leaving? It is not leaving. 3 number is not a minterm. To say it is redundant. To say it is redundant. If it is covering terms which are covered by essentials only. So if you are going to this non-essential, is it covering minterms covered by essentials only? No, because this is covered by non-essential. So these two are from essential. This is from essential, but this is not from essential. And coming to this one, what is it here? These two are by essential. This one is by essential, but this one is not from essential. So this one is not redundant. This one is not redundant. When can we say it is redundant? If the terms covered by this are from essentials only. So these two are selective prime implicants. No redundant terms here. To say it is redundant, it must be covering minterms only covered by essentials. But if you are observing this non-essential, in which we have this minterm, which is not covered by essential. So in this grouping also, because two non-essentials, first it must be non-essential to say it is redundant. To say it is redundant, it must be first non-essential. We should go with non-essentials only. If it is covering minterms only, covered by essential, then it is redundant. But no, it is not by essential. So here it is also not from essential. So two are non-redundant, but these two are selective prime implicants. If you are talking about redundant and selective. हाँ मजा आएगा मजा आएगा हाँ हाँ. Let me take one more example. See, find number of prime implicants, number of essential prime implicants, and minimal expression of function. Find number of prime implicants, number of essential prime implicants, and minimal expression of function. How many prime implicants? How many are essential? Very good. Very good. Okay. Let me do that. Yes. This is one grouping which is prime implicant grouping, right? Second grouping which is prime implicant grouping. Third grouping which is prime implicant grouping. Fourth grouping prime implicant grouping. Fifth grouping, yes, prime implicant grouping. And also we have one more. We have one more. This is also prime implicant. Check it. We cannot expand this side. We cannot expand this side. We cannot expand this side. Then you may be getting it out. Why is it required? We don't worry about required or not while grouping for prime implicants. Whether it is prime implicant or not. Yes, it is prime implicant. Yes, it is prime implicant. Yes or no? You cannot expand this side. You cannot expand this side. You cannot expand this side. Yes. Yes. Right? Yes. So, total 6 groupings are possible. Prime implicants are 6. How many are essential? How many groupings are having special cubes? How many groupings are having special cubes? How many essential? How many are essential? Yes, yes, yes. 100%. Sahil Singh. Where is the seventh one? You might be doing a mistake. Check it. Yes. In this, if you are observing, yes, this grouping is having special cube. Check it correctly. This grouping is having special cube. Essential. This grouping is having special cube. Essential. This grouping, no. This grouping, no. This grouping, no. Yes. This grouping is having special cube. Essential. This grouping is having special cube. Essential. Right. No more groupings are having special cube. Check it. Right. Now, let us see coverage of minterms by essentials. How many essentials? How many EPI? Only 2. This quad is essential. This quad is essential. No more groupings are having special cubes. Out of 6 groupings, only 2 groupings are having special cubes. So, essential prime implicants is 2 only. Yes, coverage of minterms by essentials we have seen. Then, what is the minimal expression? Essential AC. Essential BC bar plus there are 2 minterms which are not covered by essentials. There are 2 minterms which are not covered by essentials. Right? To cover these 2, if I choose non-essential, if I choose this one, covering only one. If I choose this one, covering only one. If I choose this one, covering the both. So, with minimum complexity, this grouping is covering 2 minterms which are not covered by essential prime implicants. So, what is that here? A bar, B bar, D. A bar, B bar, D. Correct? A bar, B bar, D. Anything else is required? No. Already completed. Functionally complete. Yes. The essential prime implicants is 2 only. Why do you get 3? Yes. Right. Now, if you are observing clearly this grouping, if you are observing this grouping, in which 2 minterms covered by essential, 2 more minterms covered by essential. That means this grouping is perfectly redundant. Any doubt in that? Because this non-essential prime implicant is covering minterms which are covered by essentials only, confirming it is redundant. Remaining selective. This one selective. This one selective. Right. This one is pakka redundant. Why? These 2 are covered by this essential. These 2 are covered by this essential. Then this quad is covering minterms which are covered by essentials only. Right. Now, you might be getting full clarity about the prime implicants, the essential prime implicants, and redundants, selective prime implicants. Everything you must get clarity. Anyone has any doubt? Anyone has any doubt? Essential prime implicants 2. Minimal expression is only 1. We don't have a other possibility with same complexity. Yes. Yes. Prithviraj. Yes. Yes. Yes, Anand Kumar. Yes, Rajita. Yes. So this example is a specific example which I've been taking because mostly you might be forgetting this one possibility, one mistake. The other things are you may be getting that essential prime implicants 3 because when you don't have this one also becoming essential, right? Then there will be 2 redundant. If you are doing mistake, one by one mistake leads to all other mistakes. If you are not grouping this one, essentials becomes 3, and this is becoming redundant. This is also becoming redundant. When you are considering only without considering this grouping. If you are considering this grouping, then this only redundant essential prime implicants are 2. Huh? Yes, yes, yes. Shivalila, if you are observing, is this grouping prime implicant or not? Check. Can I expand this side? No. Can I expand this side? No. Can I expand this side? No. This 2 cube grouping cannot be expandable. A grouping which cannot be expandable is prime implicant. I have been mentioning clearly while grouping for prime implicant, whether it is required or not required, we should not think. Only whether it is a grouping which cannot be expandable or not. If it is a grouping which cannot be expandable, it is a prime implicant grouping. Annapurni, wait. I'll give you. Yes. Mangesh. Now, this is redundant. Correct. Why? It is covering 2 midterms by essential. These 2 are covered by essential. So, 4 midterms, 2 are covered by this essential, 2 are covered by the second essential. So, these are covered by essentials only, confirming it is redundant. But coming to selective prime implicant, it is selective prime implicant, it is selective prime implicant, it is also selective prime implicant. 1, 2, 3. Selective prime implicant. It is not AC, Ashish. Yes, okay. If you are understanding, fine. Okay, okay. Okay, fine. Feel confident, learn correctly, should not do any mistakes. Why people are raising hands? I'm not going to give any chance. Nitesh Kumar, Revant Kumar, please down the hands. I'm not giving any chance to talk now. Okay. So next is finding minimal expression in POS. We are going for minimal expression in POS. Minimal expression in POS. Minimal expression in POS. No, we don't get 2 expressions. We don't get 2 expressions. We get only 1 expression. Yes, Suryateja, wait. If you want to consider other possibility, what is it? This plus this. What happens here? For example, for you, if I write, please don't take this one. Someone is asking me about this. Yes, these 2 are essential. Then to cover these 2, if I choose this plus this, what happens? Let us see. What is here? It is A bar, C bar, D plus if I take this one, what is it here? B bar, CD. B bar, CD. Complexity is more than this. So it is not a minimal expression, first of all. It is not a minimal expression because complexity, with lesser complexity we have here. Why do you want to consider that another expression with more complexity? With the same complexity, if you are having one more, then we get multiple minimal expressions. Here we are getting only one minimal expression. Very good. Good doubt. Because some of your friends may be having same doubt. Yes, we are getting only one. Reason is with same complexity we don't have other possibility. Other possibilities are there to cover, but other possibility is covering with more complexity than this. Then I cannot consider this one as a minimal expression because its complexity is more than this. If complexity is same for these two, then would have considered the two minimal expressions. Anna? Yes or no? Okay. Okay. Surya Teja. The only person is waiting for a break. Right? A bar, B bar, D also redundant or not? Right? Okay. A bar, B bar, D. A bar, B bar, D. How can it be redundant? So, is it covering midterms covered by essentials? No. Why are you getting doubt? Who is that? Revant Kumar. So, A bar, B bar, D is this, right? Is this covering midterms covered by essentials only? No. How can I say it is redundant? First of all, it is there in the final expression. In the minimal expression, it is there. Revant. Are you there? Okay. Anyway, we are going to see next topic, minimal expression POS. So let me take a break. Before that, we'll continue after the break. Okay. Welcome back. Minimal expression in POS, product of sums. So far we have done SOP using minterms in the K-map. We have found minimal expression in SOP. Now we are going to see minimal expression in POS. Let us see what we can do in this. Minimal expression in POS. Many are still had to join. Is it audible? Is my video clear? Is it visible my screen? Are you there? Are you there at systems? Yes. Okay. Okay. Yes. Thank you. Venkanna. Video. Please check. Few have been saying that problem is there. Change the device or change the settings in your device or reinstall that Zoom. Yes. Okay. Assuming everyone is back, let me go with this. What is it here? Minimal expression POS. What we want to do? Minimal expression POS. What can we consider? Maximums in the K-map. In the K-map, maximums are given, or even though minterms are given, we can consider maximums to find minimal expression in POS. So what we do in this minimal expression POS? For minimization of Boolean expression in POS, simple thing is we are considering maximums in K-map. We are considering maximums in K-map. The input combinations for which output is 0, we are considering K-map. Our aim is to cover all the maximums with minimum complexity. Once again, same scenario. What is it here? Our aim is to cover all the maximums with minimum complexity. With the minimum complexity. For that, grouping is similar to SOP. Elimination of variables is similar to SOP. Considering respective groupings which are covering all the maximum with minimum complexity, going through each and every grouping by eliminating variables which are changing, by considering variables which are not changing, we are writing sum terms of individual grouping. Then taking product of all these. Once again, grouping is similar to SOP. Elimination of variables is similar to SOP. Considering variables which are not changing in a grouping, we are writing sum term. A small difference you need to observe. While writing sum term, 0 is uncomplementary, 1 is complementary. Once again, the difference is while writing sum term, considering variables which are not changing in a grouping, in that if a variable is 0, uncomplementary, if the variable is 1, complementary. For example, in a grouping AB 0, 1 which are not changing, then sum term will be A plus B bar. AB 0, 1 which are not changing. A is 0, A uncomplementary. B equals to 1, B bar. So A plus B bar. Similarly, whatever we have done in SOP, what is that here? While writing product term, if AB 0, 1 is not changing, what we have written? A bar B. Product term is what? A bar B. But here, if AB 0, 1 are not changing in a grouping, then A plus B bar is sum term. Once again, while minimizing in POS, our aim is to cover all the max terms with minimum complexity. Our aim is to cover all the max terms with the minimum complexity. For that, grouping is similar to SOP. Elimination of variables is similar to SOP. Considering variables which are not changing in a grouping, we are writing sum term. Difference is 0 uncomplementary, 1 is complementary. Right. For that, let me take one example to get more clarity. A simple K map with max terms of A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. If I say these are max terms, if I say these are max terms, then what we can do? Grouping. This is one grouping, this is second grouping. In this grouping, C changing from 1 to 0 should be eliminated. In this grouping itself, A equal to 0, B equals to 1, resultant sum term is A plus B bar. Correct? C changing from 1 to 0 should be eliminated. A equal to 0, B equals to 1. So writing sum term is A plus B bar. And again in this grouping, C changing from 0 to 1 should be eliminated. A equals to 1, B equal to 0 are not changing. So another sum term is A bar plus B. A bar plus B. I hope you are following. What is it here? In this grouping, C changing eliminated. A equal to 0, B equals to 1 are not changing, A plus B bar. In this grouping, again C is changing and A equals to 1, B equal to 0 is not changing. So A bar plus B. For the same, if I write a minimal expression in SOP, to write minimal expression in SOP, we need to consider min terms. We need to consider min terms. A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Then what is it here? If these are min terms, remaining are max terms. Sorry, these are max terms, remaining are min terms. Yes, these are min terms. Assuming completely specified function. What is that? We will get clarity soon. So, if these are max terms, remaining are min terms, assuming completely specified function. What do you mean by that? You will understand. Right? Yes, this is one grouping, this is second grouping. Then what we get here? In the C changing A bar, B bar. In the C changing AB, 1, 1, it is AB. For the same function using max terms POS, using min terms SOP. Are they same? Are they same? Must be same according to our earlier discussion. SOP, POS are giving same functionality. So with respect to this function, these are maximum, these are min terms means I am writing two expressions using maximums in POS, using min terms in SOP. Then let us see A and A bar 0, A bar and B bar, A bar, B bar, plus A and B, AB, plus B bar and B is 0. Then A bar B bar plus AB. So both are giving same functionality. They are not different. They are giving same functionality, but two different expressions. Right. Now, let me take one more example. Moving to next slide. Find minimal expression in POS first, then SOP also. Find minimal expression in POS and also in SOP. Find minimal expression in POS and also SOP. Let us see what can we do. First grouping. This is one grouping. This is second grouping. And this is third grouping. There is vertically another fourth grouping. Right? This is essential grouping. This is essential grouping. This is also essential grouping. Now, these essentials are covering all the max terms. And this one. This vertical quad is becoming redundant because it is covering maximum which are covered by essential groupings only. So this one plus this one, sorry, and this one and this one, these three are sufficient to cover all the maximums. Then let me write expressions. This grouping is A bar plus B plus C. I hope you are able to write this. AB 10, A is 1 is A bar, B is 0, B, and C is 0, it is C. And what about this grouping? A is changing, B equals to 1, B bar, and similarly, D equal to 0, it is D. And also this one, what is it here? A equal to 0, D equal to 0, which is A plus D. Is A plus D. Right. What about this one? C plus D, but which is becoming extra, unnecessary, redundant. Let me use. Let us find minimal expression in SOP using minterms. using minterms. Then groupings 1, 2, 3, and 4. Once again, if you are observing essential, 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 this is becoming non-essential and also redundant. Why? If you are observing this grouping covering minterms, this one is by essential, these two are by essential, this one is also by essential. It is covered by essentials only. Then this vertical one is becoming redundant. Yes. Let me write a minimal expression. What is it here? A B bar C plus B D plus A bar D. A bar D. Moving to next slide. Simple. Covering all the maxims with the minimum complexity. Find minimal expression in SOP as well as POS. Yes. Chakrabarti, wait. Yes, I'll show you. So people are asking about the 14th slide. Moving to 15th. Find minimal expression POS and also SOP. Now, first one is if you are observing octave, then quad, and one more quad is possible, but here also again you might be observing it is redundant. Why? This grouping is covering two maxims covered by essential grouping, two maxims covered by essential grouping. Then that is becoming redundant. So octave in which AB changing, C changing, D equal to 0 is not changing, so it is D. And this quad in which D changing from 0 to 1 and B changing from 1 to 0. A equals to 1, A bar and plus C. Now also this quad, what is it here? In which A changing, B equals to 1, C, D changing, C equals to 1 means in this B equals to 1, C equals to 1, B bar plus C bar. B bar plus C bar. B bar plus C bar. Similarly, use K mapper to find minimal expression SOP for same function. Minterms. I'm writing minterms. Groupings, if you are observing 1, 2, and 3. Again, these two are essential. This is essential. This one is also essential. This is becoming redundant. This is becoming redundant. Observe correctly. A bar, C bar, D plus B bar, CD. B bar, CD is the minimal expression. Once again, one more example. Find minimal expression in POS. Okay, no problem. I will show you all the slides. If you want me to show at the end, I'll show you all the slides. I don't have any issue. 14, 15. Now we are in 16. 14, 15, 16. Find minimal expression in POS and also SOP. Right. Grouping. First one is octave. Next quad, 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 and also a quad. These are possible groupings. Now, in these, let me say essentials. Octave is essential, special cubes are there. Quad is essential because of special cube is there. Quad is essential because of special cubes are there. Right? Let us see coverage of max terms by essentials grouping. Octave, next quad, next quad. There is one max term. There is a one max term which is not covered by essentials. First, let me write essentials. Octave, what is it here? D. Quad, A bar plus C. And again quad, A plus C bar. Then here one max term is there. To cover this one max term, we have one possibility and second possibility. This possibility is resulting A bar plus B bar. This possibility is resulting B bar plus C bar. Then which one should I consider? Again, any one. A bar plus B bar or B bar plus C bar. So again, we are getting two minimal expressions. Don't think that only in SOP we are getting multiple. Yes, in POS also we can get a multiple. We can get a multiple. Similarly, for SOP, for the same function, let us find SOP. Let us find SOP. If you find any difficulty, please mention in the chat box to help you. I'm always ready. Or you can wait at the end to get clarity about the concepts. This is one grouping, this second grouping. Then this is giving A bar C bar D plus A B bar C D. A B bar C. Moving to next slide. right? Grouping, this is one grouping, second grouping, third grouping, which is becoming redundant. Once again, what we can write? A bar plus B bar, this grouping, and this grouping is A plus B bar, A plus B bar. Similarly, if you write SOP minimal, if you write SOP minimal, how it can be done, right? Right. Let us write minimal expression SOP. This is one grouping, second grouping, and also corner grouping is also prime implicant grouping. But again, corner grouping is becoming redundant. So this grouping is essential A B bar, and this quad is essential A bar B bar. This is A B bar. This is A bar D bar. Corner grouping is again redundant because already all the minterms are covered by these two itself. Solve this question. Right. Now, let us write K map to find minimal expression. What is given? Let us see. A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 1, 3, 4, 5, 7, 8, 9, 11. Right? This is one grouping, second grouping, no doubt it is a third grouping, and it is fourth grouping. Then what we are getting here? A bar, C bar plus A bar D plus B bar, C bar plus B bar D. Yes, option C is correct. As we know that SOP POS are functionally equal, let us find one more expression in POS. A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Then max terms. Then grouping. This is one grouping, this is second grouping. Then this grouping is giving A bar plus B bar. The other grouping is giving C bar plus D. C bar plus D. It is also there in the option. It is also correct answer only. But both cannot be the correct answer if it is given for only one. So if it is multiple choice questions or multiple select questions also, we cannot choose both. Even though it is multiple select question, we cannot choose both. Yes, functionally both are correct. One is SOP minimal, other one is POS minimal. But finally, if you are expecting a minimal expression of this function, what is it? So let me write expressions and decide the complexity. A bar C bar plus A bar D plus what is the next one? B bar C bar plus B bar D. Another one is A bar plus B bar and C bar plus D. Assuming all the literals are available, if you are implementing this using two levels, only. I should not use again R followed by R followed by R. No. So you can write A bar C bar, A bar B, B bar C bar, B bar D. And what about this OR gate? And again OR gate, take AND of these two. Here A bar, B bar, C bar. What is the complexity of this number of gates plus number of inputs of each and every gate? 1, 2, 3, 4, 5 gates. Number of inputs 2 plus 2 plus 2 plus 2, 8 plus 4, 12. How much is that? 17. Complexity of this expression is 17. What is the complexity of this? 1, 2, 3 gates. Number of inputs 2 plus 2 plus 2 is 6, 9. Which one is having less complexity? Obviously this one. Yes or no? Obviously, this one is having minimum complexity. Then, in the previous one, this cannot be the correct answer. This can be the correct. So, don't think that as minterms are given, options must be in SOP only. No. So, they may be giving correct answer in POS also. When both expressions are there, what is it? SOP minimal as well as POS minimal. Then complexity should be decided. Then only we can take a decision whether SOP is correct minimal expression or POS correct minimal expression. Right? Expecting such questions. What is given till now is while minterms are given, options are given POS. While maxims are given, correct option is given in SOP. When both are there, this is one possibility I'm expecting question. It is not given till now. I'm expecting this type of question also in the coming exam. They are reaching to next level. Next level means obviously next is this only for minimal expressions, because estimating complexity is important. When you know the complexity, we can say what is the correct minimal expression in SOP as well as POS also. POS also. Yes, yes. Yeah, many of you have answered correctly. It is not C and D, it can be D only. Otherwise, sometimes for the same question, I'm going to modify that. Please understand this. First, I'm modifying the question. The function f of a comma b comma c comma d is equal to dash. Then which option is correct? Then which option is correct? Now it is multiple select question. The function f of a comma b comma c comma d equals to sigma m of 0, 1, 3, 4, 5, 7, 8, 9, 11 is equal to dash. Which option will be correct, or which options will be correct? Right? What is the answer? Yes, yes, yes. If it is a multiple select questions, which one can be the correct answer, or what are the correct options? All. We are saying C and D. All. Listen carefully. It is all. It is A, B, C, D. Right? It is A, B, C, D. Guess why? It is not asked minimal. The function equal to. Very good questions already they have framed. Answers may not be in the minimal. It can be functionally equal. Point should be understood correctly. What is that here? It is functionally equal, sufficient. Need not to be minimal. Need not to be minimal. Let us see what may happen. All option A, B, C, D, all are correct. See what is happening here. Let us see. Why option A, B also correct? I am proving. I am proving how A and B also correct. Multiple select question. A, B, C, D. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Then what is given here is like this. If I group like this, I'm not grouping for minimal. This is 1, this is second, this is third, this is fourth. What we get? See, A bar C bar plus A bar D plus A B bar C bar plus A B bar D. A, B bar, D. Correct? A, B bar, C bar plus A, B bar, D. Then, is this functionally correct or not? Correct. It is correct. How? Let us see. If I take a C bar common in these two, further simplification is possible. A bar plus A, B bar. In these two, if I take D common, what we get here? A bar plus A, B bar. Then what we get here? C bar. A bar plus A and A bar plus B bar. Am I right? Distributive law. A bar plus A, B bar is nothing but A bar plus A and with A bar plus B bar. In this also, once again, A bar plus A and A bar plus B bar. Right? So C bar and with A bar plus B bar. D, A bar plus A is again one, A bar plus B bar. So A bar C bar, right? B bar C bar, A bar D plus B bar D. Is again same we are getting. Is again same we are getting. So this is also equal to this. Further simplification is possible, but functionally equal. What is asked here? It is not asked minimal expression. So the function f of a comma b comma c comma d equals to the numbers is equal to. It may not be minimal. It may not be minimal. The other one more expression is there. Let me do that also. Just a minute. Need not to be minimal. Functionality equal or not? Yes, it is equal. Then A, B, C, D 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Then min terms I am writing. And what we get? This is one grouping. This is second grouping. And this is a. Then B bar, C bar plus B bar, D plus A bar B, C bar plus A bar B, D. This is what option B. This is what option B. If you are again simplifying same as we have done here, we'll get a minimal expression in SOP. That you can do. That you can do. That means in this right, this one is correct, this one is correct, this one is correct. Because all these are functionally equal. Right? Multiple select questions depending on the question framed. If it is asked the function equal to, it can be option A, option B, option C, option D. Functionally equal, need not to be minimal. Need not to be minimal. Right? So, if it is multiple select question, if it is minimal expression in SOP only, Srinath, if it is minimal expression in SOP only, then we can go with that. Or instead of giving option D, if it is another option is given, then no doubt we go with that option C. So for example, instead of giving option D, it may be given wrong option. Then option C will be correct. Srinath. I hope you understood. Yes, if complexity is same, all are correct. Okay. I hope I'm doing my best to reach expectations of GATE and ERC questions. Understand correctly? To be functionally equal, need not to be minimal. To be functionally equal, need not to be minimal. If I say minimal, once again, it may be given in SOP, it may be given in POS. All are in SOP expressions. Then no doubt we should go with the SOP minimal expression, choose correct one. If all are given in POS minimal, we can go with POS minimal and verify. Right? So sometimes minimal expression may be given in POS and question may be framed with min terms. Another possibility, question may be given with max terms, minimal expression may be given in SOP. When both are there, complexity is playing a major role. When both SOP minimal, POS minimal is given, and if it is asked for minimal expression, then obviously complexity playing major role. If complexity is same for both, then again multiple selector. Again it becomes a multiple selector. If SOP minimal, POS minimal, param, it is not given, expecting. Mr. Param. Yes. Someone is asking for 19th frame. Go through these. Huh. I would like to ask a question here now. Are you learning anything new? Are you learning anything new compared to what you have earlier? Triveni, are you not learning anything? You know everything about this? Triveni is not learning anything new. She knows everything, I think. Okay. Sharanya, slow phase means if I speed up, right, many will be, right, out of this lectures. And we go right. Yes, Shubham Kumar, if it is mentioned only uncomplimentary variables are available, then I need to go with the number of inverters also. What is the complexity of inverter? One gate, one input. And it may be required to compare like this sometimes. Listen. Next level of this is this. What is it here is sometimes SOP minimal expression complexity, POS minimal expression complexity is same. Listen carefully. SOP minimal expression complexity is same, POS minimal expression complexity is same. Then sometimes in these two, one maybe requires a less number of inverters to get complementary variables. Again, complexity can be compared, including inverter complexity. Including inverter complexity. If it is mentioned only uncomplementary variables are available, you are getting two expressions, maybe in SOP or maybe in POS, maybe one in SOP, one in POS, maybe having same complexity, but number of inverters required may be different. That complexity also can be included. Right. Right. Yes, Shubham. Yes. You are in right way. Proceed. Naveen, what is the use of 17 means? Its complexity is 17, its complexity is 9. Which one is having less complexity? This one. That is the reason we are going with this one as a correct answer for minimal expression. So this is also minimal expression SOP. This is minimal expression POS. If you are comparing complexity of these two, because these two are functionally same, which one should I implement? Anyone. Anyone can be implemented because both are giving same functionality. Then I should go with the minimum complexity one. Ha, yeah, na. Yes or no? Minimal itself is least complexity. Sahil, minimal itself is least complexity. Right. If anyone is having any more doubts, I will wait for them at the end. Let me cover one more concept in K-map. What is that? What is that? What is that? Right? Right? Right. Don't care. What is don't care? What is don't care? Please respond. Don't care is don't care. Yes, 0 or 1. Okay. Satvik at the end. Right. Don't raise the hand now. Right. Yes. Okay. Stop typing. I can understand what you are thinking. Yes. Very good. Good answers. Its value doesn't affect functionality. Any value between 0 or 1. What is between 0 or 1? Rajendra Kulakarni. Between 0 or 1 means, do we have fractions also? Right? Okay. Okay. Generally, we have an opinion that it is 0 or 1. It is 0 or 1. But in reality, it is not 0 or 1. What is that? Let us see. It is neither 0 nor 1. In reality, it is neither 0 nor 1. Why? How can you prove that? What is the concept you are using to say that it is neither 0 nor 1? Let us see that. So first of all, why we are getting don't care? Why it is named as don't care? Then how do you utilize don't care? These are three steps we are following. First, why we are getting don't care, why it is named as don't care, how to utilize don't care, sir. These are the three things we need to understand. Yes, don't care. When I'm using an input, sir, follow my words correctly. Don't deviate from the discussion. When I'm using an input, sir, how many input combinations possible? 2 power n input combinations possible. When I'm using an input, sir, 2 power n input combinations possible. The concept I'm discussing with respect to don't care will help us in sequential circuits also, in combination circuits also, it will help us. Please follow correctly. Instead of assuming something about don't care, let us see what is exactly don't care. Then we can understand don't cares in combinational, don't cares in sequential also. Please focus on my words. Yes, when I'm using an input, sir, total number of input combinations possible is 2 power n. But according to system functionality, the system is not getting 2 power n input combinations. System is not getting 2 power n input combinations. That means there are some input combinations for which there is no possibility for occurrence at all. The environment where I'm using this system, there in that conditions, it is not possible to get all the input combinations. It is not possible to get all the input combinations. Then what should I do? We are defining system functionality for the input combinations for which there is a possibility for occurrence. For these, we are defining output is 0 or 1. Follow correctly? We are defining output 0 or 1 for the input combinations for which there is a possibility for occurrence. There are some more input combinations for which output is not defined as 0, not defined as 1. There are some input combinations for which output is not defined as 0, output is not defined as 1. Why it is not defined? According to system functionality, those input combinations never occur. That is the reason it is not defined as 0, it is not defined as 1. Such combinations are called don't cares. The input combinations for which output is not defined as 0, not defined as 1. Such combinations are called don't care. Why it is not defined? Those combinations never occur. According to system functionality, there is a possibility for occurrence some of the 2 power n input combinations only. There are some input combinations for which output is not defined because they never occur. As they never occur, it is not defined as 0, it is not defined as 1. Yes, try to understand correctly. Which combinations are don't care, sir? The input combinations for which output is not defined. Why it is not defined? Those input combinations never occur. Those input combinations never occur. That is the reason it is not defined as 0, it is not defined as 1. Such combinations are called don't cares. Such combinations are called don't cares. Try to follow correctly. Which combinations are don't cares, sir? The input combinations for which output is not defined. Why it is not defined? Those combinations never occur according to system functionality. The input combinations for which there is no possibility for occurrence, for those it is not defined as 0, it is not defined as 1. Such combinations are called don't cares. Then what is system functionality? Expected input combinations, expected output. Expected input combinations, expected output. What about remaining combinations? What about remaining combinations for which output is not specified? I don't care. I don't care what system gives the output for those input combinations. What it gives doesn't matter here because I am not going to apply those input combinations at all. One by one, I'm going to address once again, follow correctly. When we have n inputs, 2 power n input combinations are possible. In these, it is not possible to occur all the input combinations according to system functionality. For example, simple example is BCD, binary coded decimal. We are using 4-bit vector. I'm going to discuss this once again after getting into combinational. Hold on. So we are using 4-bit vectors for representing decimal digits 0 to 9. Am I audible? 0 to 9 are represented with 4-bit vectors. 0 to 9 are represented with 0, 0, 0, 0 to 1, 0, 0, 1. If I am fixing inputs is BCD, that means it is possible to occur from 0, 0, 0, 0 to 1, 0, 0, 1. What about remaining 1, 0, 1, 0 to 1, 1, 1, 1 never occurs. That is the reason for these 1, 0, 1, 0 to 1, 1, 1, 1, output is not defined. Those combinations are don't care now. Why? Those combinations never occur. Why? I'm fixing inputs is BCD. Natural BCD means it should be applied 0, 0, 0, 0 to 1, 0, 0, 1 only. 1, 0, 1, 0 to 1, 1, 1, 1 impossible to occur because I'm fixing inputs in BCD. Then 1, 0, 1, 0 to 1, 1, 1, 1 are considered as a don't cares because they never occur. According to system functionality, input should be applied BCD only means it is possible to occur from 0, 0, 0, 0 to 1, 0, 0, 1. Remaining never occur. What are those? Don't case. What should be given for 0, 0, 0, 0 to 1, 0, 0, 1? Output is specified. 1, 0, 1, 0 to 1, 1, 1, 1. Output is not specified. Output is not specified as 0. Output is not specified as 1. Such combinations are called don't case. Right? So, the combinations for which output is not defined as 0, not defined as 1. Such combinations are called don't case. Why it is not specified the output? They never occur. According to system functionality, those combinations never occur. Those combinations never occur. That is the reason what should be the output? I don't care. Because according to system functionality, they never occur. Then what should I take care about that? No, because I don't care what system gives the output. Then what is system functionality? Expected input combinations, expected output. Remaining, I don't care. Because we are not expecting what should be the output for these combinations for which output is not specified. What about system functionality? Expected input combinations, expected output is a system functionality. One by one. Whatever I addressed, please understand these words correctly. With these words only, you are going to apply this concept in combination as well as sequential. When can I use don't care? How to utilize don't cares also we can understand from this concept only. Try to focus on this. Once again, when we are using n inputs, two power input combinations are possible. For each and every combination, output is not specified. There are some input combinations for which output is not specified as 0, output is not specified as 1. Sampath Kumar, please wait. So there are some input combinations for which output is not defined as 0, not defined as 1. Why it is not defined? Those input combinations will not occur, never occur. That is the reason output is not specified as 0, output is not specified as 1. Such combinations are called don't cares. Such combinations are called don't cares. Why? System functionality is expected input combinations, expected output. What about remaining? What about remaining? What system gives the output for these input combinations?
Hello. Dear students, today class has been cancelled due to the power cut. Power cut till now not solved. Today class has been cancelled. Tomorrow, as usual schedule, 2 to 6 digital.